Hello, everybody, and welcome back to the Ambition into Action special series of the EPRI Current podcast. Thank you so much for joining us for another episode of this Global Forum for Nuclear Innovation special series. We've got another couple of excellent guests to talk to today. I hope you're as excited as I am to hear from them. For those of you who haven't been following along, the Global Forum for Nuclear Innovation is as you might imagine, a global consortium of all sorts of research organizations aimed at improving the adoption of innovation practices and cultures around the industry. And they've sponsored this special series of the podcast so that we can bring on both nuclear industry experts as well as experts from other industries to share their knowledge and experiences with turning ambition into action and taking bold steps in various areas that we've identified as areas of growth and opportunity for the nuclear industry. At the prior Global Forum for Nuclear Innovation, they identified a number of grand challenges that we've been discussing and working on over the last couple of years, all of which will culminate in the Global Forum in Miami, which, as of the airing of this podcast, should just be in a couple of days. So see you all there. The topic that we're discussing today is safe doesn't have to be slow. And this is a particularly interesting one. But before we talk more about that, let me introduce my fantastic guests. Steve Rader is a program manager at NASA responsible for all things innovation. And David Smeatham is an engineering consultant at Inuvo who comes from a, storied background with the UK regulator for nuclear energy. I am very excited to have you both here as guests. Thank you so much for taking the time to join us and talk about the really acceleration of innovation in a very specific area. So when I think about safety, and I think when a lot of people think about safety in these very regulated industries because of the impact they can have on society, sometimes it's technology focused, but a lot of times it is practice, process, and regulator focused, because no matter how much the individual company looks to improve their safety through the application of technology or procedure, ultimately, it comes down to the regulator to protect the safety of the public. And that's often what the general public is most interested in as we deploy these fascinating technologies, rocket ships, nuclear power plants, all sorts of cool stuff. So my first question is really for David. The role of the regulator is to ensure that the public has the safety expectations that they won't be harmed as we put these new technologies into practice, but they want to not inhibit the growth of that technology. And oftentimes that comes down to a balance between different competing priorities. So in your experience as a regulator, how have you treated innovation, both from industry and within your own organization?
Great start, Dan. Great question. So, fundamentally, you hit the nail on the head before when you said that when we're looking at this, safety is paramount. The whole role of the regulators to ensure society is protected from any risks from technology, whether it be nuclear or rockets falling out of the sky, those sort of things. So, but when you're thinking about innovation, there's often a lot of uncertainty associated with that innovation. So the process of regulation for the innovation is a process of ensuring you're taking adequate steps to mitigate the risk that comes with that uncertainty. And so and often when you're thinking about that, things that we choose to look at to say that this is what safe looks like, or this is what good practice looks like, they're not there for innovation either. So it's tricky. There's two strands to that. One, there's loads of innovation, there's loads of uncertainty. And second, you don't have a benchmark to say what good looks like. So in my view, the key thing to do there is to try and get people together, diverse backgrounds, to work out what that good practice is and how we manage to reduce that uncertainty in order to deliver the innovation, the improvements from that innovation.
The crafting of groups of diverse backgrounds is something that I think has a lot of benefit whenever I've tended to approach a problem. A lot of times when, working through a group project in school, they try and pair up different different disciplines of engineering when we were given a common problem, because while a chemical engineer and a mechanical engineer, they have completely different backgrounds. They're going to approach problems from different perspectives. And so that mindset change as you all look at the same thing is a pretty interesting practice. Now, in when I think about NASA, I often think about this rapid progress, this fascinatingly efficient innovation. You all have taken some massive steps. I mean, we had never been to space, 70 years ago, and then we put people on the moon pretty quickly after that, which is just incredible when you think about it. When you all consider innovation, what are some of the ways that you try and push innovation forward? What techniques do you use to enable these jumps in progress without compromising safety?
Yeah, well, I'm glad you think of NASA that way, because we love to be that. But we face the same challenges anyone who's worried about safety faces, which is it's hard. And the danger for us is once we have something that seems to work, it's kind of terrifying to move to the next level, right? Because you've done all this work, it was hard. Don't introduce anything new into the system. Let's just keep the status quo. And so there's these forces, right, that are really there. But we live right now in an amazing time where the rate of new technology being introduced and really the volume of technology coming into the equation is tremendous. And those technologies have a lot of promise to help us with our safety and to help us with our capabilities. So it's not like we want to just stop there. We have to keep going. But it does take pressure, because I think engineers and scientists, once you get to something that works, you want to exploit that as much as you can. And so there's always this tension between operating and keeping something going and safely, and introducing something new. So I actually run a center of excellence at NASA, where what we focus on is how do we deal with that rapid change, and how do we introduce technologies into the system so that we start evaluating them and studying them and incorporating them and to leverage the new capabilities they've built. And then we do that through open innovation. So that's what my Center of Excellence focuses on, which taps into the very diversity that you're talking about, right? Which is we tap into 50 different curated crowds around the world. These are commercial platforms that invite crowds in that total something like 200 million people. So we have access to many, many people. And what we do is we get with the folks that own the different capabilities that we're trying to progress, right? So we call them problem owners, right? Because you have this capability and you need it to be this much safer, or this much lighter, or this much more reliable. And we basically take that on as a problem and say, okay, how do we make that a challenge that we can open up to the rest of the world and bring all of the smart people in? There's a stat that came out of a guy from Harvard, where he kind of looked at the growth of the population of the world and how education's moved forward. And he came up with a stat that I found fascinating, which is an estimate, but that 90% of all scientists that have ever lived in the world are alive today. In other words, the 10% that wrote all the textbooks that I studied in school, they're all dead, right? But, most of them are dead. But that's how many people are working on new solutions and progressing technologies and making things safer. And we want to leverage that. And if you think that you're able to access within your own industry, then you don't really understand how big that push is and how much technologies are developing independently in other industries. And so open innovation allows us to find those people that can connect the dots and actually find ways to bring those solutions to bear on our problems. And we call it finding the best innovation starting point. It's not replacing your own innovation. It's simply getting you started with all the best ideas, experts, and technologies. So that's an intro, kind of how we're working and what we're trying to do. But we have the same pressure that before anything flies, you have to have analyzed and tested and make sure that it meets your expectation. I think where we hit the speed bump in the regulation piece is that we have a lot of bureaucratic processes, and it's hard to keep those processes moving forward when you have lots of different organizations involved. And so we have to really be diligent about bringing people together and making those decisions quickly and having clear thresholds that we're trying to meet.
That is such an interesting approach. Open innovation as a way to effectively crowdsource the ideation step of innovation, because I'd imagine the implementation of a lot of those ideas then goes back to the problem owner or whomever is the sort of the engineer in charge.
Yeah, sometimes it really depends. We have an entire ecosystem that feeds us with companies. And so sometimes we're trying to bring that in so that we can develop it. Other times we're trying to actually stimulate the growth of companies that can be our suppliers. We don't want to be the supplier of everything. And in fact, if you've watched NASA over the last, 15 years or 20 years, we've really started commercializing a lot of our core capability. Getting into low Earth orbit is now something NASA doesn't do as a core capability. It's something SpaceX and Blue Origin and different vendors do. Boeing just launched their new Starliner. So we do care about trying to stimulate companies that can do this, especially now that there's a larger economic ecosystem around it. But now the safety job is something we can't do all by ourselves. So there's a lot of what we do at NASA when we work with commercial is setting some of those standards for, if we're going to put US astronauts on a vehicle, it has to be human rated, and therefore it has to meet a whole bunch of criteria, which includes all that testing and redundancy that we need.
When you're going through that process, the technology readiness level that NASA developed, that seems like a really helpful framework to, we're talking before about uncertainty and reducing that uncertainty. You've got a methodology there that's systematic, that allows the development of a technology or a process that and kind of has those gated processes that really provide confidence or lack of confidence, if necessary, about the development and the deployability of that technology. Is that still a key part of the kind of programmization of the work that you do?
Yeah. And for those that might not know, technology readiness level, or TRL, is kind of a 1 through 9 rating, where 1 is kind of an idea that's not been proven. 2, you start to get it in a lab and start to demonstrate it. By 3, you've got it a little bit more mature. By the time you get to 9, you actually have to have demonstrated it in the mission. So it has to have flown in space and actually worked within the context that you want to finally have. So we have a whole bunch of test programs along the way, so that when you can actually get something to a producible and it's demonstratable on a terrestrial level, you still have to go fly it in zero gravity or get it into a vacuum chamber and all of those steps to get it into the environment. And I'm sure you guys have something similar, David, where, you can do things outside of a radiation environment, but to actually test something in a real in situ environment, that's sometimes very expensive, right? And so you want to find ways that you're doing that analytically first, and then moving on. But yeah, we use that all the time now. The trick here is, with all of the technology development going on worldwide and the introduction of some new tools, it's hard to keep up. That system helps us that when we do find something new, we can evaluate it on that and then target, okay, now what has to be done in order for us to adopt this into our system? And that's helpful in kind of getting clarity on it. And we have a whole bunch of facilities and test labs that kind of facilitate that. Like we have a flight opportunities program that will take technologies and fly them in various spacecraft or low Earth or balloons, depending on what you're trying to test. We have vacuum chambers, both small and large. We have radiation testing environments. So all of those are very helpful to have that infrastructure to move that along. But, we're talking about speed. Some of the things that slow us down there are you don't have enough facilities for the demand sometimes, right? So that can be a real bottleneck. And they're very specialized types of facilities. So trying to right size that with the demand curve is often part of the issue.
That's certainly a struggle the nuclear industry has when it comes to radiation capabilities. We have all of these new materials that we want to test for all these different neutron spectra and reactors, and we don't have enough to satisfy the demand, and we're losing access at this point instead of building more. So it's certainly a challenge.
I think you're hitting on something that's really an important component of what we try to do when we're attacking some of these problems. And that is, a lot of times in the technical areas, we want to find a problem and we want to go solve it. And engineers will just try to identify a problem and then put it up on a whiteboard and start trying to brainstorm ideas. And that's actually the absolute worst thing you can do. What we really emphasize is this idea of really understanding the problem well before you start trying to solve it. When we have an accident, we put all the cracked minds on what went wrong, and we do a root cause analysis, and we really try to do. I think we should do that same level of analysis on hard problems, like how do we get things certified faster so that we can actually get to the root cause of each thing? Because often it's not the technology, it's the bureaucracy or the process or the training or the configuration management or the facilities, as you just mentioned. And if we do that, it helps us to focus on the things that really help us move forward rather than getting distracted by the shiny thing, which is often the hardware. And we leave things like software kind of dangling out there, or we leave test facilities this kind of like, why would we ever invest more in that? Well, if they're key components to the performance that you're trying to get, you can easily afford them in the larger context, because if you don't have them, you wait and it wastes a lot of money. So
that process improvement is something where there is a lot of opportunity, I think, for the nuclear industry to accelerate the both process of regulatory review, I think, through the adoption of some technologies to optimize the use of the human experts on the teams of the regulators who, as you pointed out, with the growth of the number of technologies that we have to look at, the individual regulator is being tasked with understanding far more things than they've ever had to be an expert on in the past. In the nuclear space, this is not just, the introduction of, for instance, artificial intelligence and machine learning to the process of operating a plant or of evaluating materials compatibility, but also just the sheer volume of fundamentally different technologies that the regulator has to understand. We built our regulations on the, generally, UK not included, the large water-cooled reactor. The UK, of course, has a lot of experience with the gas-cooled reactors, but still a relatively singular technology. And now we see gas-cooled reactors, liquid metal-cooled reactors. You see liquid fuel salt reactors, and the amount of knowledge that a regulator has to have to be able to adequately ensure the safety of these systems is, it's probably growing parabolically, realistically. So, David, from your experience, either with the technologies like AI or with some of these new reactors, what are some of the ways that there can be process improvements to enable the regulator to be able to even just handle the volume of things being thrown at them today and in the next 10 years?
So I think there's two aspects of that. And I'll give you an example of some work that we did when I worked in Office of Nuclear Regulation in the UK. So set up the Innovation Hub, which was intended to try and accelerate the safe adoption and secure adoption of innovation in the nuclear sector. But in doing so, when you're thinking about innovation, I mentioned before about that uncertainty associated with it. And when you think about artificial intelligence and the regulation of artificial intelligence, read any newspaper now, and there'll be an article in it about how do we regulate this, what's the best way of doing it. So there isn't an established way of regulating artificial intelligence. So set up in the UK a sandbox, a regulatory sandbox. The idea was to get a diverse set of people together around the table that we can look at a couple of applications about artificial intelligence that the industry developed they developed a mock safety case. And then it allowed us to have an early discussion. So they were based on Chatham House rules, which is basically you close the door, everyone's got a voice, but any comments that are made aren't attributed to a particular person. So it allows the regulator and licensees and other experts to get into a room early doors. Steve, you mentioned about getting started. This is all about getting started and having an honest, warts and all conversation about the benefits of AI, the challenges of AI, how you might regulate it, what will good practice look like. And unusually from a regulatory perspective, I was in that room making suggestions of solutions, which is, you never go there as a regulator. It's not the regulator to kind of define solutions to things. But if you're talking about hypothetical cases and you're exploring how you might do something, it's absolutely appropriate that the regulator expresses a view in that safe environment. And it was really good. So we looked at 2 applications and we came up with ways in which you could deploy artificial intelligence in the nuclear sector. I was doing some reading the other day. I was going to pick up a quote that's by Nancy Leveson, who's an MIT professor. And she said, safety is a property that emerges from how an entire system fits together. And it's very much that. You've got people, you've got process, you've got plants, technology, and it's about all that system coming together that produces safety. It's not one component. Safety isn't a bolt-on. It's got to be engineered right from the beginning. But having that system view of it is really valuable. So that's the first example of kind of how in the UK we thought about the application of AI in a nuclear sector. And to be honest with you, we hardly talked about AI. It was all about the protection systems that go around the AI so that we can get the benefits of the AI without the disbenefit of its kind of uncertainty, as we were talking about before. You've got a system around it that protects if anything were to go wrong. So that's the first example. The second example was that systematic view. And Steve was mentioning about having lots of looking systematically about what we do in a highly regulated environment. And maybe we should point the lens at ourselves and think, okay, how could we regulate more effectively, efficiently, maintaining standards, but doing it in a different way? Often when you've got people involved in that, systems perspective doesn't really deal with people very well. We tend to deal with technology quite well. But there's technical, like soft systems methodologies that allow you to develop a systematic view of a people and process and plans that helps you understand, not looking for a solution in it, but looking to get closer to the issues, to the problems, the opportunities, and teasing those out. But the issue being that if you think too constrained and thinking it into physical systems view, you might think you've come up with the answer, but you probably haven't, because it hasn't taken into account the complexity of people. And what soft systems methodology does, it allows you to bring in that people aspect. And so you don't put all your eggs in the basket that's actually wrong. You're actually specifying the problem better because you're taking into account people's view in that as well. So two things. First, getting people together, talking honestly and in a safe environment really accelerates the thoughts and opportunities and challenges associated with the technology. And secondly, dealing with people and culture is critical to this, to make sure that we get something that works in the end.
So David, can I ask you, this is so fascinating because I love the way you were talking about the process of safety really being a system, because I think that is this key thing that's going to make it something where you're instrumented, you have measurements, you're trying to actually get to a performance level that's understood. I was curious when you're talking about decision making and how you communicate, because there's now these blockchain-based decentralized autonomous organizations, or DAOs, that's kind of what they've started to do, is implement decision making capability in the smart contract kind of layers. And it would be really interesting to see if both workflow digitization as well as decision making, I don't want to say automation, but highly structured decision making, right? That's enforced by a digital system starts to help move the speed of that faster and faster. Because I know one of the things DAOs are well known for is how fast they can operate large numbers of people in the decision making chain.
Yeah. So the decision making is really important, really critical, but so difficult, isn't it? When there's faced with this amount of uncertainty. Give you an example of how we got to that when we were looking at the applications of artificial intelligence. One of the applications that we looked at was if you're looking at the structural integrity of a component, so how likely a piece of kit is, a pipe that's going to fail, or a strut or something like that is going to fail. And how can you use artificial intelligence, taking plant data, taking inspection data, using AI to kind of give you a prediction about whether you can change the proof test interval, the way you do maintenance on it? Can you extend that? Do you need to make it shorter? Those sort of questions, which have a knock-on safety implication if you get that wrong. And the key thing is someone's got to make a decision along the line about whether it's appropriate to extend that proof test interval or not. AI has got a view, but we talk about human in the loop. The difficulty with human in the loop and AI, there's all that trust, or mistrust, or overly pessimistic or optimistic trust that you've got within the system. So the answer that we came to was that we have groups of people together to, in reality, now not using AI, to make these decisions. We get that diversity of views by getting a group of learned and experienced people around the table to make a decision. And we don't want to throw out the benefits of all that. But if we had someone around the table who was also representing reviews of the AI, so a person who's purely representing the views of the AI, you're maintaining the benefits of the system that you've got, but you're also allowing yourself to the benefits of the AI in a controlled way. So it's not incumbent on one person to make that decision. You're maintaining the kind of benefits of that group decision, but you're also introducing the AI into that as well. And so we thought that was a pragmatic way of trying to get the best of both worlds. But we got there through a process of exploring the challenges, the problems, the opportunities associated with AI. It wasn't, it was by getting that diverse group of people together, we're thinking, okay, how do we take this and put it into our normal working practices in nuclear so that we can get the benefits of AI in a safe way?
I really like that, because it's not the either or, right? It's the what do you get when you add. And I was thinking about things that affect safety are, did the human do what they said they did correctly, right? And configuration management and monitoring. And it seems like there's a real opportunity with the way AI and video are capable, and proliferation of video, where you almost could have constant eyes on critical hardware that watches every single thing that's done in detail, and have AI watching that. So there's actually an opportunity to get, a lot better chain of custody with, blockchain has this really great way to keep chain of custody work, along with video, along with other sensors that can provide you almost constant understanding of what your hardware is going through and did it. And that's such a big part of safety is that piece, right? There's proving new technologies safe, but then once you're operational, that's probably the bigger cause of safety issues is simply kind of getting the operations wrong. So I like that approach of AI as the addition, and new technology as an additional piece. And then eventually, if you see that it's going to replace something, you can kind of wean it off of some older tech.
It even gives you some of the opportunity to bring along the newer workforce, because at least in the power plants, half the operators that you talk to who have been there for a long time walk into a room and can tell you exactly which ball bearing is going and which piece of turbo machinery just by hearing, but they can't explain how they know. but having that reproducible data logs allows you to point to trends that you can then use to help teach someone who can't necessarily walk into a room and be like, yes, it's that bearing over there that's busted. And now I know why, because I can see it, learn it, then understand it, and then apply it. So that's both a good way to maintain the chain of custody, a good way to double check, and also probably a good teaching tool as well, which is always important as we're trying to, triple the capacity we have installed, which is going to require a lot of people we don't currently have trained.
One of the things that we're having to deal with is around this new workforce. And one of the things that we noticed about, 7 or 8 years ago is this big change in the workforce that's going on, where experts used to be able to go tell them, hey, we've got a job here, we want to hire you and come in the workforce. And the full-time local position was easy to hire. And we're finding now that a lot of people are interested in the gig economy and working as consultants and working more as independent workers and remotely, to the point that we've actually added pieces to our contract where we are trying out these new models to find not just people, but the right experts. There's so much going on in the tech world that's introducing new skills and new expertise that we're finding the recruit and retain model is kind of breaking, because you can't actually hire on all of the different skills you need because we don't have a good offboarding process and a good way to actually transition our workforce. So we're really struggling with this, because then a lot of companies I've talked to have a hiring freeze and a skill shortage, which kind of reflects that. You're trying to onboard all these new people. And if you think about it, 20 years ago, you could have one IT person that ran, 50 computers, and, it wasn't that complex. And now you have to have a cloud engineer and a cybersecurity person. Like, you literally have to have a staff of 15, almost regardless of what you're doing in IT. But you don't necessarily need a full-time cybersecurity. You need these niche capabilities. And you see it in companies. You see a lot of kind of micro slicing of time because you're trying to address these problems internally. I'm curious, how are you looking at that? How are you thinking of that? And how do you see it affecting the safety environment?
So I think a lot of that comes down to knowledge management, and that we IAA been doing some work on innovation competency, which I've been involved with. When we were discussing that, and there'll be a document that comes out in due course on that. When we were discussing it, we were discussing about the roles around innovation, and we honed it down to 3. So if you want to deploy innovation, you basically need 3 roles represented. One of them is a specialist in terms of the technology, the process that you want to, the innovation that you want to do. That needs to be conceptualized into where you're trying to apply it. So you need a specialist in the application as well. And then the third one is a specialist in the process of innovation. And between those three groups, you can see that you've got someone who's representing that phased, process that's going to be kind of make sure it's safe, but also getting the benefits, which is a difficult balance to get. But you're also getting the benefits of the people who are maybe in the gig economy that have got that deep specialism in the innovation. But the contextualization of that into the nuclear sector, getting operators, getting specialists in maintenance on nuclear power stations, was really key to kind of round that circle. So it's about knowledge management, I think. But then AI can help you there. We in the nuclear sector, we spend, as you probably do in space, we spend loads and loads of time capturing lessons learned. Do we always learn from lessons? Because we generate all our knowledge, but do we actually use it? AI, machine learning, would be brilliant at that. You could type into an equivalent to ChatGPT and say, "This is happening. What have we done? What have other people done in the past?" You've got humans in the loop around that. So it's just a great way of using all that knowledge and getting the benefits of it in a rapid, timely manner.
I will tell you, we have that same struggle on lessons learned. One of the struggles we have is capturing it, right, and getting it somewhere. And AI is providing ways that you can then access it. One of the things that we've been doing that's been quite successful in kind of enterprise knowledge sharing is that we have a challenge platform internal to NASA. So we have about 30,000 employees that are members of that. And we'll put a question out that says, hey, we're trying to solve this problem. Does anyone know anything about solving this problem? And what we find is it's the antibody response that actually gets the sharing, because people think, oh my gosh, somebody's working on what I work on. Don't they know I'm working on? It's kind of a paranoia. But it's really wonderful in that the human network is that component of, oh, don't you know so-and-so is doing this, or I did this. And it bubbles up that very knowledge that you're hoping for. So it is both that kind of finding the information and then leveraging it at the right time. And I'm hoping that we can use that to add to the corpus of the lessons learned that might not be captured through the rigorous lessons learned process, which is not perfect, as you know, right? You can't capture quite everything.
And how great would it be to share those kind of platforms? Because we all benefit, don't we, from sharing knowledge about lessons learned, especially in the areas of safety and security and environmental protection. There's no commercial aspects associated with that. It's just good for society, isn't it, really? And what's good for you could be good for us as well. It would be great to kind of explore sharing those lessons learned more widely.
It is very important to make sure that you can catalog that knowledge that you see coming up from this antibody response adequately, because that's institutional knowledge that is very person dependent. And I think that's somewhere that we've seen some challenges in the nuclear industry. Is in the 50s and 60s, you had some of the smartest minds on the planet developing technologies that, 60 years later, now we go back and we look at the reports and we say, this really is insufficient to communicate everything we needed to know. But all the people who worked on it have since passed, and they didn't really take good enough notes. And regaining that knowledge requires experimentation again, which is a real shame because we know it was there. So that practice of digitizing, of maybe making hard copies, and then a thought from a prior podcast strikes me is that to solve this sort of like the fractalization of IT and everything else, the over-specialization, well, you can't get everybody. But if you have a log of the knowledge that's required to be capable, then you hire the people and you train them on the knowledge. And yeah, maybe you get that gig economy worker to come in and give them a year of this on-ramp to what they need to know. But you hire the person who's going to stick and who's going to, believe in the mission, is going to stay, because you can train them on anything you want, but not necessarily the other way.
Yeah, it's kind of crazy. We've actually found in the gig economy, you can find almost any experience level that you want. We think of people in industry, but we forget there's a real life cycle of people that come in and out of industry. And we've actually tapped into some retired folks that were fully up to speed on what it was, and in fact, more knowledgeable than the folks we had. And I think especially as the baby boomers are starting to retire, that construct, if we learn to use it right, is going to give us the ability to tap in so that it's not just this binary loss when they leave, that we have this kind of ability to still engage some of those assets as they go. But not just them, right? Also being able to get folks who are maybe experts on quantum sensing and some of the newer technologies that are playing out in modern systems.
I think that also having people from all those different backgrounds and different experience really helps as well, because you're getting a diverse view. You're getting the cross-fertilization of ideas. Industries aren't siloed or are less siloed going forwards because you're getting that kind of greater circulation of knowledge and experience, which it's only going to help. And we talked previously, didn't we, about opportunities, so framing things in terms of problems and framing things in terms of opportunities. I found that working with new graduates, they tend to have a very positive and opportunities-based focus. Whereas the more, I'm really stereotyping, apologies, but the more you get in your career with all those lessons, all those things that you've learned over your career, you tend to be a bit more pessimistic and kind of cynical about things. So having the diversity of views around you, I think, is really helpful to balance those behaviors.
All right. Well, that is pretty much all of the time we have. Steve, David, thank you so much for joining me today. This has been enlightening. As with so many of these prior podcast grand challenges, everything seems to really come down to the people, how you integrate a culture of honest information sharing between people of different backgrounds, of different organizations, of different intentions for the technologies and the processes that we want to improve. And seemingly safe doesn't have to be slow is just like everything else. It requires people to work together towards a common goal in good faith. And I really appreciate all the different techniques and opportunities that you both have shared with us to really conceptualize how we could do this in the nuclear industry and in other industries. Thank you so much. It has been a pleasure. And for everyone else, I hope I will see you, I guess, in a couple of days in Miami for our final podcast of this Ambition into Action special series. Thank you all so much, and I'll see you soon.